Yep. Hi, morning, everybody. We'll make a start. My name's Jason Reed. I'm the sales manager for Pilz in the UK, and I'm here today to talk about the changes to the machinery directive becoming a regulation and the impacts of that with industrial security. So the agenda today, I'll run through the changes to the machinery regulation. We'll talk about cybersecurity standards. We'll talk about IT versus OT, possible side effects to the safety control systems. We'll run through risk assessments, zones and conduits, what we call foundational requirements to IEC 62443, and then we'll run through countermeasures. So there's quite a lot to get through. If you have any questions, then if you've got time, I'll answer those towards the end, or our stand's just across the way there. Come and see us afterwards. So safety and security. So security vulnerabilities really enable machine safety to be manipulated. And we're all familiar with machinery safety and how that protects your staff from hazards due to the machinery itself. But now we need to look at security and protecting your machine and data from manipulation from unauthorized access, so from people. And we need to look at security in two different ways. So we need to look at the physical security. So that's protecting the machine from personnel. So how do we protect unauthorized people gaining access to the machine through gates, covers, flaps, or through HMIs, for example. And then finally, we need to look at information technology security, which is protecting the industrial devices and data from attackers. So, for instance, from outside attack. Machinery regulation. So we're familiar with the machinery directive. That's now becoming a regulation, and we achieve compliance through harmonized standards. But now with the introduction of the machinery regulation, that now incorporates industrial cybersecurity. And again, as a result of that, there's around 600 to 700 standards that we need harmonizing to allow us to achieve compliance from the 20th of January 2027. So how's that process happening? So some of the main changes to the machinery directive are with the regulation is we need to look at protection against corruption, and there's a focus on functional safety standards and the functionality of safety with regards to security. We can do that at present by looking at 13849. So there's some requirements there for access to functional safe controllers. It puts an emphasis on the skills of new employees, and it talks about access for qualified personnel only to the controller. We have what we call NIS2, the Network and Information Security Directive. So as it currently stands, that looks at just what are called essential entities, so like water, gas, utilities. But it now incorporates what we call important entities, which are employees of more than 50 people, if you have a greater turnover of 10 million euros as an example. And what that does is that it looks at measures for managing cybersecurity risks. And then we have the Cyber Resilience Act, and that puts an obligation on manufacturers of products with the digital element. So, a company such as Pilz, if we manufacture a product and we can see that there's vulnerabilities with that, we need to be able to communicate that to the marketplace and make them aware of those vulnerabilities. But more importantly, how can you mitigate against those? And finally, another standard that's in the process of being written is protection against corruption. And that is EN 50742. And that addresses the requirements of protection against corruption to achieve compliance to EHSRs for the machinery regulation. So what are the most significant changes really concerning security with the machinery regulation? So AI is not mentioned specifically in the regulation. It talks about the inclusion of so-called emerging digital technologies, but it's quite clearly recognizable through those terms. It's got the inclusion of cybersecurity and associated safety requirements. We have the requirements for human-machine interaction. and psychological stress. So it's down to manufacturers to try and make the usability of HMI interfaces, etc., more easy to understand and interface with. And then there's requirements for authorization and access rights, which are in relation to the safety and reliability of control systems. So the key changes are AI technology. There is no direct reference to the NIS directive, and that's quite important, really, because obviously the UK is not part of Europe with regards to the regulations with Brexit, and the UK government has already said that I believe they won't take the NIS directive on board. So as a result of that, a lot of people believe that we will fall in line with the machinery regulation, the changes that come about, and that would have proved an obstacle. We have to look at protection against corruption, and what the machinery regulation states is that the machinery product shall collect evidence of a legitimate or illegitimate intervention in the software or a modification of the software installed of the machinery, and that's its product or its configuration. And that's to do with the HSR 1.1.9. And then if we look at 2.1, we look at the safety and reliability of the control systems. And it says that they can withstand malicious attempts from third parties, shall not lead to hazardous situations, shall be protected against accidental or intentional corruption. So it's quite important there, because what we're talking about is not just somebody in their bedroom trying to hack into your system or a state-sponsored attack. It could even be an employee that makes a mistake. So, I may have seen John clear a blockage using the HMI last week. Same situation happens this week. I go to clear it using the HMI. It causes an issue and a conflict. I didn't mean to do it, but I need to protect against that, because it was, it wasn't intentional. It was a mistake on my part. So how can we do that? Just some other requirements from Annex 3. So connection of additional equipment must not lead to loss of a safety function. So if you've got Wi-Fi connection, if you've got other Ethernet ports, etc., that are on the machine, remote access devices must not affect safety. Hardware components that are important for connecting and accessing safety relative software must be adequately protected against unintentional and deliberate corruption. I'll stress that point again. The machine must collect evidence of lawful or unlawful tampering with the hardware. It doesn't go into detail about how it will do that, whether it has to be electronic or paper or etc., but that's stipulated. Software and data relevant to software shall be identified as such and adequately protected against intentional or unintentional corruption. The machine must collect evidence of tampering with any safety-related software, and the machine must identify the safety-related software that's installed. So conclusion to the regulation is that Pilz, we interpret the regulation to mean that it's mainly about protecting the machine from a security point of view. So it's via security measures. And as mentioned, from January 2027, so it's from the 20th of January, manufacturers of machinery must conform to the machine, must ensure that the machine complies with the machinery regulation, which will mean that it also must include aspects of security. And if it fails to do that, then your machine would no longer be CE compliant. So a quick overview of the changes to the regulations. So for manufacturers of electrical equipment, we have machine builders, we have critical infrastructure, such as utilities. They are potentially all under attack. And so for manufacturers, depending on the turnover and the number of employees, NIS2 is important, but the Cyber Resilience Act is a must. For machine builders, NIS2 is important, but they must conform to the machinery regulation. And then for critical infrastructure, it's essential. So what standards can we use? So for cybersecurity, there's two that we generally use at present. We have ISO 27000, and that really is around about information security management systems. So it's organizational. What kind of industrial information security management systems should we have in place? What kind of guidance do we have for implementing those? What kind of monitoring, measuring, analysis, and evidence kind of collation do we have within the organization? What kind of training do we give to our employees to ensure that there's compliance, etc.? And then we have IEC 62443, which is security for industrial automation and control systems. And that's really around the application and the product. And again, you can see here, depending on the part, it's broken down to component, product, and factory. How does it look between safety and machinery? If we look at a kind of a life cycle or development, so we always start with a risk assessment for safety, and we'll use ISO 12100 to do that. We'll determine the risks of the machine. We'll look at the performance levels or the safety integrity levels. But when it comes to security, we'll look at 62443 or 27000. We'll look at the risks that could occur through manipulation, and we'll look at what we call the security level. When it comes to the requirement specifications for machinery safety, we'll do safety concepts. We'll look at access management to the machine. What kind of distance protection do we need for light curtains, etc. For security, it will be the same, but we'll do security concepts and protection against unauthorized access. When it comes to design, we'll then go into detail on those safeguarding protection measures. So, if it's a light curtain, it might be 2 meters high, it might be 5 centimeters away from the hazard. With security design, we'll look at user management on the engineering workstation, let's say, or segmentation of the network that it sits in. We'll then implement those measures for both. Then when we look at verification and validation for machinery safety, we've got well-defined normative guidance for both of those. And we can actually verify that our design meets the requirements, for instance, using 13849. But when it comes to security, we can verify the security measures, but it's very difficult to actually validate those because you have to introduce some kind of risk into the machine itself, as in a breach. For a cycle with a machine, you generally build it, supply it to your customer with a CE mark on there. It probably won't get touched for 20 years, whereas with security, you're going to have vulnerabilities that become known over time. Very similar to your phone. You might get a new patch come every week or every month to say that you need to do an update. With your machine, you can look at websites such as CERT at VDE as an example, and that will tell you what kind of vulnerabilities there are and how you can overcome those. You'd have to risk assess them. You'd have to look at device management for your machine. There'll be more communication between the OEMs and the end users themselves, because you're going to have that dialogue as vulnerabilities are known. Then you've got your patch management. So that's really in the event of a safety critical failure on a machine. Whereas for security, if a vulnerability impacts the functional safety, then you're going to have to apply any mitigating risks against that. And so, like I say, there'll be more interaction between the machine manufacturer and the operators. This is kind of our cycle that we use for machinery safety. So again, we start with our risk assessments, our safety concepts, safety design, system implementation and validation. We have international standards, and we've got regulations that we use for that. And normally with a machine manufacturer, we stop at this point. But for security, we'll do the risk assessment, we'll do the concepts, we'll use our standards, we'll do our design, we'll verify that, but we won't stop at this point. It will be an ever-evolving process during the machine life cycle. So, differences between IT and OT. We're all familiar with the IT network, with the operational network. We kind of do what we call the CIA method. So we look at confidentiality, integrity, and availability. So for confidentiality, we want to ensure that our data can only be read or modified by authorized users. Integrity, data may not be unknowingly modified. And then for availability, we want to prevent system failures. And depending on whether you're in an IT or an OT network, that's going to change. Your priority is going to change. Typically for IT, you want to make sure that you've got your confidentiality. You want to make sure you're GDPR compliant, etc. Nobody's going to take any of your IP, for instance. The last one's typically availability. If a laptop fails, for instance, or a printer fails, you can just go and get another laptop, and set that up quite easily. When it comes to OT, it's kind of reversed. Availability generally is the highest priority because you can't go and just get another production line out of the stores. Yeah, you need to make sure it's always available. And then, integrity and confidence you can change depending on your circumstance. But what we also have then is the introduction of safety. So what are the possible side effects? So if this is our safety control system, if we look at the security, there may be a threat. And if that's exploited or succeeded, that would lead to a vulnerability. If we can look at that vulnerability, that would have a consequence. It might be on an asset, so that could be a component or a human. It may be that there's loss of business, there's business interruptions. You just got to look at Jaguar Land Rover, for instance. Or it could lead to a security risk to the safety control system. And if it does that, then it goes over to machinery safety, and we could have a failure or manipulation of the safety control system, i.e. the safety functions are no longer performing as intended. That could then lead to degradation of the risk control measures. So it may be that we've blanked the light curtain, for instance, or we've made its stopping time longer, and that could have a consequence and lead to harm. So how do we overcome this? So we'll do that with zones and conduits, and I'll use the analogy of an airport. So we're all familiar with going on holiday on the airport. Normally, before you get there, you'll get all the rules of what you can and can't take. There'll be security checkpoint rules. There'll be public announcements. These are all familiar and examples of 27000. These are all the management side. It's all information. Then we have the physical security measures, which are kind of in line with 62443. So we'll have video surveillance, regular police controls. You'll have your identification and authentication. So at the ticket counter, am I the person to get on the flight? Do I have a ticket? At the border control, who am I? Am I allowed to leave or enter the country? At the boarding gate, am I allowed to board the plane? And if I'm airport staff, do I have a card that allows me access to restricted areas? So any airport, really, we can segment into zones. So we've got the green zone, which is our general public area. So that could be the departure. Then we've got our red zone, which is the ticket zone. In addition, each gate, we've got a blue circle and a blue line, which indicates where the gates are. And in order to move between those two zones, we have to create conduits. And these will have specific rules that are defined. So an example, to move between the green zone to the red zone, I need to pass the security checkpoint, which is in yellow, and I need to have a valid ticket. I need to be able to go through the screening. I need to have a passport, etc. And such checkpoints between these zones, with their different rule sets, are like firewalls within our IT and our OT environment. So if we look at what we call our system under construction, this is our IT. Everything in the red box we're going to have as our OT, and we're going to start to group all of our components together. So we put all our safety in yellow, let's say. All our industrial automation we might put in blue, all our Wi-Fi in black, for instance. So we'll start to create those zones. Then what we'll do is we'll then look at the communication between those zones, and we'll carry out a risk assessment, which I'm not going to go into, to define what kind of control measures we'd put in place. An example of such would be here, you've got a HMI, you've got a functional safe controller, you've got your automation network here. We're going to zone it, so you can see green for automation, yellow for safety, blue is for external ports. We've got a firewall from the outside IT network. But if you want to gain access to your functional safe controller, so you want to prevent manipulation, the only way to do that is with an RFID key, and that would allow access through the HMI, the USB ports. You can't gain access via the HMI to the controller, which you potentially could because it's on the same network, unless you've got the right protocol through the firewall. There's a lot to go through there. So we're separating our networks, we're reducing the communication, we've got additional authentication, and it's kind of an acceptable level, really, of effort for the safety. What I've just shown you really are what are called foundational requirements to IEC 62443. And really, there's 7 of those. Identification, authentication is one. Use control, system integrity, data confidentiality, restricted data flows, so like firewalls, VPNs, timely response, and then resource availability. And our countermeasures really are, well, I imagine it is very much like if you had an access gate to a machine, you may have a light current or an interlock on there. That's the way you mitigate your risk. These countermeasures are the way that you'd mitigate your security risk. And so we have what are called safeguarding support systems. And what a safeguarding support system will do is it will identify who the authorized personnel is. You've got verification that the authorization for that selected tasks matches the identified personnel. So if they're going to change a program on the HMI or gain access to the machine, you can verify that. You inform the user of the authorized task, enable the mode of what we call safe operation. So if you want to change the machine from a run mode to an inch mode, and then you can specify the zones to which authorized personnel have access. And what this effectively means, that mechanical, anonymous mechanical keys that are typically left in a panel where you're having a run mode, an inch mode, a test mode, they will be phased out because you've got no way of being able to identify and authenticate who is doing that task. And so to give an example of safeguarding support systems, it's basically like a passport or a driving license. You identify who that person is, what are their responsibilities, what's their training, etc., the competency, and then you've got the access management. So it's a way of being able to gain access to HMIs, safety PLCs, doors. You've got safe operating modes, machinery safeguarding, so you could log personnel in, so like intelligent lotto, and then you've got your machine security measures. And so I'm close for time, so I'll show you some examples, really. So here's a typical panel. You can see you've got your key trapped in the panel. You've got your USB and your Ethernet ports at the bottom. So you've got no way of identifying who's doing what to the machine. Key's always inserted. You've got direct access to USB and Ethernet ports. And so a way of being able to mitigate that is afterwards, you'd have a remote RFID key. That's defined to each user with all your permissions. And if you've got the right permissions, it would allow you to gain and enable these USB or Ethernet ports or change the mode of the machine. If you're not trained, it wouldn't allow you to do it. Another example really would be remote access to a machine. So you can see we've got a client PC that could be in Spain. This could be our machine in the UK. They've got all the correct VPN protocols to gain access, but we've got an additional layer of protection with a firewall and a VPN. And we're using our key here. So once I've verified who this person is, if they're authorized and able to gain access, I'd put my key in and I would allow them access to the machine. When I remove that key, it removes their access. And then finally, this one's to do with access to the HMI. So depending on my skill set would depend on what I can actually gain access to on the HMI. So when I put my key in, everything in green here I've got access to, but other parts I haven't because I'm not trained, competent and authorized to use it. Yep. And that would depend on your competency. And then if you wanted to gain access to a machine, you'd be familiar with trap key, mechanical trap key. With this, you'd put your key in, you'd log yourself in, you'd go in, but you could leave through any door, but you can have multiple logins. So the more people that go in, the more you log in, and then only when the last person comes out would you be able to reset and start the machine. Any questions? There's quite a lot to take in a short time. I didn't say I could answer them, but you could go.
Could you just clarify what's happening with the UKCA marking? You mentioned we CE marking.
Yeah, so with UKCA and CE marking, I think it will be very similar to when UKCA marking first came out, that we'll get a notification on the 19th of January 2027 that says we're going to do it. But there is, as far as I understand, there's legislation going through Parliament that gives the Secretary of State powers to mirror EU direct regulation. And so if that happened, then we could just mirror the EU regulation. Yeah.
CE mark on it because we're not.
So that's still the case. Yeah. So if you're a UK manufacturer, well, so exclude UK. So if you are in Scotland, England, or Wales, because Northern Ireland is slightly different. But if you're within those three countries and you are a manufacturer of equipment, you can't You can't place a CE mark on that machine and supply it to Europe because technically you are outside the EU. Only EU member states can
Even
do
though
that.
the regulations are exactly the same.
Exactly the same, yeah. Yeah. You can CE mark a machine. This is where it gets messy. You could CE mark if it was staying in England because we recognise the CE mark. So you could CE mark a machine. If I was building a machine in Leicester, I could CE mark it and use it in Leicester. Because we accept CE mark machines. Yeah,
I know.
But if I then wanted to ship it to Europe, it would lose that CE mark status.
Okay.
That's where it's just.
Okay. I have slightly different understanding on that.
Yeah.
But yeah, okay.
But yeah, you'd need to get an authorised rep to sign it off. It'd be no different to if you're in, as it stands, it'd be no different to if I was a Chinese manufacturer. Yeah, I can't put a CE mark on there legally. I'd have to get an authorised rep to do it. Does that answer your question?
Yeah, I'm not totally aligned with it, but yeah, okay. I'll see you after. So.
Okay, all right. Yeah, it's fine. Okay? Yeah? Thank you, everybody.